Hi friends, today in this video we will discuss about availability and the reliability. Why these concepts are very important to maintain a system very effectively in the production. Okay, first we will discuss about availability. What is meant by the availability? Okay, availability means system that can operate continuously without any kind of the failures for an extended periods that can be measured as availability. Okay, system or application operate continuously for extended periods without any failure. It shows that the availability of an application. Okay, why it should be measured? Availability should be measured. It shows that your application will be continuously available for the customers. Okay, it can be measured with a metric called generally uptime metric. It is a metric used to measure the availability. Okay, I hope you can understand what is meant by the availability. Okay, what is meant by high availability then? If the system maintains 99.999% availability throughout the year, it is called known as high availability systems. Okay, in simple words, availability means if any kind of the request fired by the customer, it should be give the response without any kind of an server kind failures. Okay, it is known as availability. The availability metric is measured as uptime metric. If the uptime metric has a value of 99.9999%, that system or that application will be considered as high availability system. Okay, availability is the most important factor because, for example, in the live example, if you take then Amazon, Amazon Great Indian Sale. Even 1 minute downtime of Amazon application will cause a huge loss in the revenue. It causes huge loss. So that's why the availability metric is always plays an important key role while we maintaining an applications in the production. Okay. How we can measure an availability? How this uptime metric will be the measured? Okay. We need to understand the terminology here. Okay. First, failure happened. Okay. This is second failure. Okay. For example, if you had an application, if you are making the horizontal scaling or whatever it may be, okay, if there is some failure in one of the server in that application, it will be considered as a first failure. And later, after some time, there is a second failure will be happen. Then how we can measure the availability of the system between these two failures? Let us see. Okay. We have some parameters here. Let's learn those parameters first before discuss about this. MTTD. Okay. What is the MTTD denotes? Mean time to diagnose. Okay. What is meant by MTTR? Mean time to recover the failure component. Okay. MTTF, mean time to failure. Okay. MTBF, mean time between the failure. Okay. These are the parameters. We need to understand these parameters in detail. Okay. I am trying to explain is we had the application. We had the many components in that application. So one of the component or one of the server had a failure. Okay. There is a first failure happened. And later, after some time, there is a second failure happened in that particular component. Then how the availability of that component can be measured? We need to understand, right? To understand how the availability of the component should be measured, we need to understand about these parameters. MTTD means mean time to diagnose. For example, if the any failure will happen, first we need to diagnose a failure, right? How the failure will be happened and why the failure will be happened. What is the root cause of that failure? Okay, we need to understand that. Mean time to understand about the root cause of that failure, that time can be measured as mean time to diagnose. Okay. Next parameter is mean time to recover the failure component. Okay. If you understand the RCA, how much time you take to resolve that particular problem, that can be measured as mean time to recover that the failure component. Okay. And mean time to failure. Mean time to failure means already one failure will be happened. We diagnose the problem and later the problem will be resolved. And later, after some time, after fixed the problem, later sometime another problem will be occurred in the system. The time between the recover the problem to the time again the another problem happened, that time is nothing but a mean time to the failure. Okay. And meantime between the failure, meantime between the failure means if first failure will be happen, diagnose the problem. Okay. The later it already fixed the problem. And later after some time, the second failure will be happen. The time between the first failure happened to the second failure happened, that time can be measured as the mean time between the failure. Okay. To understand, to make a better understanding, I will give you a clear cut explanation here. First failure happened. Okay. First, what we had to do generally, diagnose. Okay. After the diagnose, fix the problem. Okay. After the fix the problem, it is running fine and second failure happen. Okay. It is running fine. Fine. And then second failure happen. Okay. This is how the component will works, right? The time taken to diagnose a problem. This period is called MTTD. Okay. Time taken to fix the problem. This period is called MTTR. Okay. The later it will be running fine. Later the second failure will happen. The time taken after fixing the problem to the second failure happen. This time is called MTTF. Okay. Now the time taken between the first failure to the second failure, this time is nothing but an MTBF. Okay. This is a parameters we need to understand. I hope you can understand these, all these parameters. Now, how the availability should measured if the application happen, the failures. Okay, how the availability is measured. Availability is equal to mean time between the failure is divided by mean time between the failure plus mean time to recover the failure component. Okay, this is how the availability is measured. Okay, I hope you can understand what I'm trying to say. For example, if you designed an application, okay, if one of the component had a first failure the production, okay, later after you diagnose a problem, the later you recover the component well, later it is running the fine, the later second failure will be happen. Okay, now how the availability was calculated for this application? The availability is calculated using these timings, using this formula. Okay, if this availability of this particular application is 99.99 percentage, then the system is nothing but an high availability. Okay, now we can clearly understand the what is meant by the availability and how the availability is measured for one particular application. Okay, now we need to understand about the percentages of availability. Percentage of availability. If percentage is 90 percentage, for example, if this particular application, it gives a 90 percentage, we have per year. I am trying to explain is this per year. Okay, per year, there are 36.5 days downtime. Okay, per year downtime. Then downtime per day. Per day, your application will be down up to 2.4 hours. If your availability is 90 percentage, then your application per day 2.4 hours, it is going to be the downtime. At the same time, the per year 36.5 days, it goes into the downtime. Okay. If your application is 99% availability, then there is 3.65 days per year there is a downtime. per day 14.4 minutes. Okay, if your application is 90.99 point just 19%, 9%, your per year there is an 8 hours of downtime and 1.44 minutes per day. Okay, and your availability of an application is 99.99%, then per year there is a 52 minutes downtime per day, just 8.6 seconds downtime. Okay, if your application is 99.999%, then per year there is a 5 minutes downtime and 0.86 seconds per day. Okay, if your application is 99.999%, per year there is a 32 seconds downtime per day, 86 milliseconds there is a downtime. Okay, I hope you can understand now how the availability is calculated for the application, why it is so much important. Okay, based upon this availability metric, how much time our system is having a downtime per year and per day, it is calculated. Okay, based on that, the preventive measures will be taken in the architecture. Based on this parameter, the preventive measures will be taken in designing the system. Okay, so that's why the availability metric is very, very, very much important. I hope you can understand very clearly how the availability is calculated for the application. Okay, this is about the availability. Now, how we make an high availability? This is very important, right? Then how we can make a system to be converted into the high availability? Okay, to make the system high availability with 99.999%, there is a 32 seconds downtime per year and per day just 86 milliseconds. Then one and only solution is there, that is nothing but an redundancy. Redundancy. Redundancy is the one of the key important factor to achieve the high availability, because redundancy is nothing but an duplicating the components. Duplicating the components. Before talking about the duplicating the components, we need to understand about architectures when we duplicating the components. Okay, so that which architecture will be suitable for a high availability. Based on the application, we need to decide. First, learn about the architectures when we duplicating the components. Okay. First one is hot cold architecture. Second thing is hot warm architecture. Third one is hot architecture. Okay, so to perform the high availability of the system like 99.9999%, we should need the duplicating the components. Okay, whether it in the horizontal scaling or whatever it may be. Okay, duplicating the components will be the required. The challenges when we making the duplicating the components is how we can replicating the data is really important. Okay, for making the replication of the data, we have a three architectures. Let's learn those about the three architectures. Then we will decide which architecture will makes us to perform high availability. Okay, let's check this hot cold architecture. Okay, we have server one. Okay, we have server one. We have another server. Now, how the data replication will be handled between the two servers. We are making the duplicating the servers, it is absolutely fine. But how we making the data replication between the two servers is plays a key role. Okay, hot and cold architecture denotes data replication will be happened periodically. For means if the request is coming to server one and placing data, okay, this data does not immediately transfer to the server 2. Okay, it data will be transferred periodically. That means for every 10 minutes or for every 1 hour, like that periodically transfer of the data will be happen between the two servers. That means two servers or three servers or whatever it may be. How many servers you are making the duplication, the data will be the transfer periodically. Okay, in this architecture, if the data will be transferred periodically, both reads and writes, all these two will be coming to the server one itself. It does not goes to the duplication servers. Okay, in the hot cold architecture. In hot warm architecture, we have server one, we have server two. Okay, in the hot warm architecture, data will be goes between the two servers almost the same, but little bit lag will be there. If there is a request will be comes to the server one, okay, and placing the data, placing the data, it takes little bit time to replicate here. Okay, this is called hot warm architecture. That means the server one is hot, this is little bit in the warm state. Okay, in the similar way, this is completely in the cold state because data will be transferred periodically. Okay, it is a hot state, immediately it is available here. Okay, in this architecture, writes reads reads and writes will be happen on the architecture, and warm writes will be happen. Okay, if the write will be happen after a little bit of small delay, it will be replicated here. Okay. Now hot architecture. Okay. We have server 1, we have server 2. So data replication will be happen immediately. This means it is also in the hot state. This is also in the hot state. Okay. Data replication will happen immediately. On this server also, read and writes will be happen. On this server also, the read and writes happen. Okay. Now you need to understand the terminology in the better way, means without any kind of the confusion here. Hot means immediately available data. Okay. That means reads and writes takes place from the hot. Okay. Now warm. Warm means slowly available. Okay. So writes only happen in the warm. Now cold. Cold, what happened for the cold? Periodically available. So if the data is periodically available, what happened? Nothing happened here. Okay. For to to make this hot and cold, hot, warm, hot, hot. So based upon your availability percentage of your target, for example, if your availability, you should have the 99.9999% availability, this hot architecture will be the required. Okay. Do you want a little bit compromised? Hot warm architecture will be the required. If you want a little bit compromise, more compromise, hot cold architecture will be the required. Okay. Now examples, the live examples for the hot cold architecture, hot warm architecture, and hot architecture is, for a hot cold architecture is a banking applications. See, banking application always concentrate on the consistency, not on the availability. Okay. We should understand the consistency and availability and partition tolerance. These are the parameters in the cap theorem in the further videos. Okay. Always the banking applications is always focused on consistency, not on availability. Okay. Just imagine if there are the multiple users are there, 5 users are there using the bank applications. If the application is down, is also the matter, but it doesn't more matter than the consistency. Okay. If your application is does not down, but still it doesn't give some perfect balance, it does not works in the banking applications. Right. Your application down, it's okay, a little bit compromise of an availability, it's okay and fine, but it should be having consistency. So in the banking applications, hot cold architecture they would focus on. Okay. In the case of the news websites, hot warm architecture they are concentrated. Okay. A little bit of late, it's okay and fine. Okay. In the case of the news applications, in the case of the e-commerce applications, your application should always available. A little bit of consistency, it's okay and fine. For example, if the product will be available for one user, if another user for another user, it takes a little bit of time to available. It's okay and fine in the e-commerce website, but your application will be always an app. So in the case of the e-commerce websites like Amazon or Flipkart or whatever it may be, it should have the 99.999 percentage availability. To make the 99.999 percentage availability, it should have the redundancy. Redundancy means duplicating the components. Okay, in the redundancy, it should follow the hot architecture. That means if the request was comes to the any kind of the server, it makes some kind of the change or it puts some data, it should be almost available for the another server. It should be the transfer, it should be available. Make sure that. Okay, it is for a hot architecture. E-commerce websites is a example for the hot com. Now we will discuss about reliability. Okay, what is meant by the reliability? Reliability means the probability of a system that work correctly without a failure for a given period of your time. Okay, probability of a system that works without any failure. Okay, that is nothing but an reliability. Now most of the people was confused between the availability and the reliability. Most of the people will confused between the reliability and availability. Let me clarify the both the terms very clearly. Okay, with an example. If you developed an application, okay, if you developed an application, application one, okay, it behaves like every 2 days, every 2 days, there is a failure. Okay, and it takes 10 seconds to recover. Okay, it is the behavior of an application. Let us consider another application called app2. Okay, this is every 6 months there is a failure. Okay, every 6 months there is a failure. It takes 8 hours to recover. Okay, this is an behaviors of two applications, application one and application two. In the first application, it has high availability and low reliability. Okay, in the case of an application 2, low availability and high reliability. I hope you can understand things better. Okay. Reliability is nothing but the probability of the system that works without any failure. That is nothing but an reliability. Whereas availability means the system will operates continuously without any failure for an extended periods is nothing but an availability. Okay. Here what will be happen? It takes an 8 hours to recover. Okay, system should continuously works without any failure for an extended periods. It is called an, it represents an availability. Here it 8 hours the system will not recover here, so it will be considered as low availability system. Okay, in the case of an application 1, it takes a 10 seconds to recover. It takes 10 seconds to recover and it is having the high availability. Okay, system should works without any kind of an failure for an extended period of time. That is nothing but an availability. The probability of an occurring a failure, which will be represented by an reliability. Okay, here the probability is for just for 2 days. Every 2 days we are occurring the failure. That means the failure repetitive is a more. Here every 6 months. That means if you consider per every year, okay, every year if you consider, if you take the statistics of per year, how many the failures the app 2 will be happening? 2 failures. Here the app 1, how many failures? It happened 365 by 2. That means 18.5 times. So that's why it is having a high reliability even though it has having a low availability. Okay, I hope you can clearly understand the difference between the availability and the reliability. Okay, to monitor these things, both reliability and availability, generally what are the mechanisms they used in the real time? We need to understand those things. Okay, first thing is monitoring and alerting. These are the preventive measures they are taking to maintain high reliability and also at the same time high availability. Okay, first one is monitoring and alerting. They're monitoring their systems. If any system had very close to CPU, like 80% or 90%, they would get the alerts. Okay, in the real time. Second thing, load balancing. Load balancing. Load balancing is nothing but an, if the if any particular of a time, if you are getting the more number of the requests, the number of requests distribution between the servers is always same. Okay, this is the load balancing will helps. Okay, and third one is automatic recovery. Automated recovery. Okay, that means if the requests are more and server capacity is less, okay, it is going to be detect that the requests are coming the more, and in future there is a chances of high traffic and available, automatically it itself increases its capacity. That is called the automated recovery mechanism. Okay, so these are the few steps. These are the few steps they need to be take care to make the systems high reliability at the same time high availability. Okay, I hope in this video you can clearly understand the differences of availability and the reliability, and to make an high availability, how the redundancy we need to be take care, and what are the architectures of the redundancy. In this video we can clearly explain. Okay, I hope if you like this video, please share and subscribe this channel. Thank you.